2.5 is really just an extension of 2.4, and I alluded to this in the last video about point slope formula, and we're going to talk about that a little bit here in 2.5. So here's point slope formula. Basically, literally, I mean, they're so creative with the name. If you have a point and a slope, then there's a formula that they come up with. And essentially what it is this over here, okay? Where this point x1, y1 represents the point that you're given. M is the slope, so this x and this y are just part of the equation all the time. And if you wanted to look in the book, it really comes from the slope formula itself. So if I just divided both sides by this x minus x1 and put it over here, it essentially is the slope formula, and that's where it comes from. So even though in 2.4 I said, all right, here's your slope, plug the point in, find the y-intercept, and then write your equation, here now we have a formula that allows us to just go straight to the answer. The problem is going to be, it's not even a problem, but the challenge that you're going to have is you're going to have to get it in slope-intercept form, and so you're going to have a little bit of work to do even after you plug the point in and the slope in, but it's not that bad. I'm going to tell you that some of these problems, you're going to follow the directions, obviously, and if the problems say use point slope formula, you're going to use point slope formula. Eventually, I'm not going to care which formula you use. It's going to be up to you. Ultimately, we just need to get the equation correct. So here's an example. So here's a good example. It says use point slope formula. So we got to use point slope formula. It goes through -5, 2, has a slope of -3, and then it wants the answer in slope-intercept form. So we're going to have to do a little bit of rearranging. So I go to my formula. I plug in the slope, which is -3. I plug in where x1 and y1 is. And so here's where that's going to look like. Y minus 2, because the y is 2. The -3 is the slope. And notice this would have been x minus -5. So that just turns into a plus. So this is in point slope form now. I've got to get it in the slope-intercept form, which means I need to get the y by itself and combine some like terms where necessary. So I'm going to end up getting rid of this -2, and I'm going to have to distribute over here. So let's distribute first. Then I'm going to add the 2 to both sides. So then I get y equals -3x plus 13. When I add the 2, -15 plus 2 is -13. It's in slope-intercept form. Donezo. Okay. You've probably done this before. Now, there's some other things involved here that we are going to talk about that you've probably seen before as well, but I want to refresh with you. Again, it all comes back to the same thing. In order to write a linear equation, we need two things. They could be 2 points, they could be a point and a slope, or it could be a slope and a y-intercept. If I have any of those two things, I can write an equation. Okay? Just kind of keep that in mind. When you know the slopes of lines, you can determine if those lines are parallel, perpendicular, or neither, which means they intersect, right? Parallel means they never intersect. Perpendicular means that they intersect in such a way that they form right angles. And neither means they just intersect in some way, okay? And if you know the slopes, then we can make those determinations. So first off, if two lines are parallel, they have the same slope. Same exact slope if two lines are parallel. If two lines are perpendicular, then their slopes are opposite reciprocals, which means the slopes are flipped from each other and have opposite signs. So for example, I'll just throw one out here. If I had a slope of 1/2, if I flip it and change the sign, the slope would be -2/1, which is -2. Two lines that have these slopes are going to be perpendicular. Flipped, change the sign. Okay, so that would be an example of two slopes that are opposite reciprocals. Opposite meaning they have different signs. Reciprocals meaning they're flipped from each other. Okay, and of course the last one is if lines are neither parallel nor perpendicular, they just intersect, then neither of these things are going to apply. The slopes will be different, and they won't be different in this way, okay? Then we just know that they intersect. So a big part of the rest of this section is writing equations that are parallel to a given line or perpendicular to a given line. Okay? So here's that example. So what we want is the equation of a line passing through this point. So it goes through this point and is parallel to this point, right? Parallel means they have the same slope. So all I need to do is come up with the slope of this line. And if I can find the slope of this line, I need to write a new equation that has the same slope and goes through that point. So I could use point slope. So first let's find the slope of this line. So the way that we do that, we find the slope of the current line. Okay, and so I'm going to get it in the slope-intercept form. So I'm going to move the x, which makes that minus x. Then I'm going to divide by 3 to get the y by itself. And so my slope is negative 1/3. Okay, which means what I'm going to do is write an equation with that slope that goes through that line, through that point. Okay, and that's what this is. Now I'm going to use point slope. Since I have a point and I have the slope, I can plug all those values in. Then we're going to write it in slope-intercept form and in standard form for my final answer. So we'll have a couple extra steps to do that. So first, let's go point slope. All right, I've got y minus 2. My slope is negative 1/3, x plus 3 since this is minus. I'm going to distribute again, and I'm going to get the y by itself to take care of the slope-intercept form first. That'll be the easiest. So I distribute here, I get negative 1/3 times x. Negative 1/3 times 3 was negative 1. Add the 2 to the other side. So my slope-intercept form is y equals negative 1/3 x plus 1. Same slope, different y-intercepts. This will be parallel to this line. Okay. So there's the first part. Now when I put this into standard form, you're going to see something kind of interesting. So first thing I did is I moved the minus 1/3 x to the other side. All right. Now I want, when I put things in, this technically is standard form. Real number, real number. When I do standard form, I want these to be integers. So I'm going to clear the fractions, which means I'm going to multiply everything by the common denominator, which is 3. So when I multiply this by 3, I get x plus 3y equals 3. So notice here this x plus 3y, x plus 3y. That's not a coincidence that those are the same. Okay, they have the same slope. The difference is going to be there on my y-intercept, which is different from the y-intercept for this problem. So anyway, third form, that slope-intercept form, I've satisfied the request of the problem, and I've showed both. The last thing I want to do is an example like this, where it says write an equation for the line that is perpendicular. So it's the same idea, right? Instead of, however, using the same slope, I'm going to use the opposite reciprocal slope and then use point slope formula the way we did before. So first, we have to find the slope of the current line. So fortunately, this one is already in slope-intercept form, so that slope is 1/6. We can just pick it off. So the slope of a perpendicular line is going to be the opposite reciprocal. So I got to flip it and change the sign. So the slope of the perpendicular line will be -6. Flip it, change the sign. So now I've got my point, I've got my new slope that I'm going to use. I can use point slope form to find that, and just like what we did in the last problem, we can go through that. I mean, I could show you what it would be and all that, but it's the same exact process as what we did on the last problem now, except instead of using the same slope, you're going to use this as a slope, use that as a point, plug and chug, and then you'll have it. Okay? So that is 2.5.